Here we go. Okay, today we're going to look, I'm going to do two harder examples, one multi-step example first of using these 5 equations for uniform acceleration. And then I'm going to do one algebraic example that uses algebra and unknown variables, like kind of solving two unknowns type idea. So two harder examples of using uniform acceleration equations. Once I'm done those two, I've got a sheet that on the Google Classroom that's got 6 or 7 practice ones there that you can work through with solutions. So if you're not from Vanguard here, I posted them on the bulletin board and I'll give you the sheets here. But if you're not in Vanguard, you can print them off from the Google Classroom here. But first 20 minutes, we're going to go through a couple of problems first. So that's where we're starting. Okay, so let me set up a multi-step problem. So first day we did one step, okay? Find the correct equation, plug in the results. Today we're going to be, you got to use more than one equation to solve your problem. So this is a multi-step example. Okay, so let's set up one here. I've got one with a rocket here that we'll work through. So I'll slide that up. Okay, so let's say a rocket is starting from rest. Okay, and accelerates uniformly. At, we'll go 3 significant figures, 12.5 meters per second squared. Okay, so this is period, and we'll get that squared in there. Okay, and how far will the rocket travel in the 5th second? Of its trip. Okay, so what we actually are asking there is from 4 seconds to 5 seconds. Okay, so this one basically uses a couple of the equations. So what do we know first of all? Well, we know that it starts at rest and it accelerates at a given rate. So those are two things that we know. So I'll do this in red, let's say. So we know that it's accelerating at 12.5 meters per second squared. And we know that initially at time 0, it's going 0 meters a second. It's sitting on the launch pad. Okay, so what we want to do is we want to find the velocity after 4 seconds. And then we want to find the velocity after 5 seconds. And then we can use this equation here. Once we have these two velocities, this one after 5 seconds, this one after 4 seconds, and then we know the acceleration and we can solve for d. So we're going to use this one first to get our velocity after 5 seconds. We know that it starts at 0, okay? So we're going to apply this one twice and then apply this one once to get the distance. Okay? So step 1, find the velocity after 4 seconds. And then step 2, find the velocity at 5 seconds. And then step 3, find the distance. traveled between those two velocities. Okay, so that's using this one twice and using that one once would be probably the easiest way. So let's go ahead and apply them. Okay, so if we start at 0, our velocity after 4 seconds is going to equal the velocity initial plus the acceleration times the time. So this is 0 meters a second plus 12.5 meters a second squared times 4 seconds that we traveled. Okay, so we just multiply those two numbers together to get 50 meters a second. So after 4 seconds of accelerating, we're going 50.0 meters per second. Why am I putting 0.0? Because I want 3 significant figures. Okay, this is after 4 seconds. Okay, now we'll do the same thing for after 5 seconds. Okay, so it's going to be same equation, but the time is going to change. That's a 5, by the way. 5 seconds. So 0 plus 12.5 meters a second squared times 5. 0.0 seconds or whatever I have. So multiply 12.5 by 5, and we get 62.5 meters per second. Okay, so now that we have the velocity at the start of the fourth second and the velocity at the 5th second, we can then apply this equation here with the v squareds in it to find, this one would be the 5th second, this would be the 4th second velocity, and we know the acceleration to find the distance it traveled. Okay, so that's our 3rd step. Okay, let's slide this up a little bit. Okay, so we're going to apply the velocity squared after 5 seconds equals the velocity squared after 4 seconds plus 2 times the acceleration times the distance. We're going to leave the distance blank and solve for d. Okay, the velocity after 5 seconds was 62.5 meters per second, and we're going to have to square that. The velocity after 4 seconds was only 50 meters a second, and we'll square that. And that's going to give us 2 times the acceleration of 12.5 meters per second squared times d. Okay, so we're going to do some algebra to solve this one. Okay. Okay, squaring this on our calculator, we get 3,906.25 meters squared second squared. 50 squared is just 2,500 meters squared second squared. Okay, you couldn't write the units in if you want, but they're meters squared second squared. And then 12.5 times 2 is 25 meters per second squared d. Okay, and these ones are meters squared second squared. I'll write them in just so you can see how the units work. Okay, and then we're going to subtract the 2,500 from both sides to get 1,406.25 on the left. Okay, meters squared second squared equals 25 meters per second squared d. Okay, now if we divide out 25 meters per second squared, 2 seconds will cancel out, and 1 meter will cancel out, and we'll be left with meters. Okay, so you take your 1406.25, divide by 25, and we get a distance to 3 significant figures of 56.3 meters. Okay, so that's what I mean by a multi-step problem. A problem where you can't just use one of the equations, plug it in, and get an answer. That's the what we did yesterday. You just plugged in one plug-in and boom, got it. Okay? Okay, there's various kinds of those that show up. You know, this one's about as complex as it gets with 3 steps in there. But sometimes you have to find a time because you're missing a time or something like that. Okay. Is there more than one way to approach a multi-stepper problem? Yeah, usually there's more than one way to get it the same answer. Sometimes there's 2 or 3 different ways you can get to that path. Okay, the second and final thing I wanted to show today before we'll just work on some practice, is an algebra question where you have unknown variables to solve. Okay, where you have to use quadratic factoring and things like that. You know, the stuff that makes the class grade 12. You know, you have the math background. That it's a little more mathematical than the other stuff. Now, in terms of this question showing up on a test, not going to happen, but it might show up on a handout. Okay, the algebra type question. I would stick mostly on the test to multi-step problems or single-step problems when I give the Unit 1 test. And of course, when we do the Unit 1 test, I'll do a full outline with everybody a couple days before we write it so that you know what to expect, especially people that aren't used to me as their primary teacher that haven't had me before. You guys are fine. Most of you guys in Vanguard have had me for a few years. Okay, so let's do an algebra problem here. I'm going to flip the page and we'll do this last example today and then let you work on some practice ones. Okay, so this is a typical algebra type problem that you might see come up. So let's say Ryan runs at a constant velocity of 3.6 meters per second. Okay, so he's not accelerating at all. He's just running at a constant velocity. Okay? Okay, Cal starts from rest and runs after Ryan. Cal starts 4 seconds after Ryan has. We'll say starts running. 4.0, we'll make it 2 significant figures, seconds after Ryan, and accelerates at 1.2 meters per second squared trying to catch it. We'll say to catch up. How long does it take Cal to catch Ryan? Okay, so this would be a typical algebra type problem here. Okay, so we have one guy running away at a speed, constant speed, and then somebody starting later and running faster, accelerating after him, and eventually catches up and tackles him or whatever, if you're playing football or whatever. Okay, so the general idea here is that the distances that they travel will be the same. Okay? Because he's going to catch him at that same distance, even though he starts later on. Okay? So the distance of one runner, say Ryan, will equal the distance of another runner at Cal. Okay? Okay? Well, we need a time in here, so we're just going to define a variable. We'll say let x be the time for Cal to catch Ryan. Because that's what we're trying to find. Okay, so that's going to be what we're trying to find out. Okay, well, if we're looking at Ryan is running at a constant velocity, okay, Ryan's going to end up running for an extra 4 seconds, right? Because Cal starts running 4 seconds after Ryan, right? So we'll say that Ryan's time will then equal x plus 4 more seconds, because Cal is waiting, and 4 seconds after he passes him or whatever, he starts running, right? That makes sense, right? So now we're going to write an equation for Ryan's distance, and we're going to write an equation for Cal's distance. Okay, so Ryan's equation is just velocity times time. So we're going to go Ryan's velocity times his time. Okay, that's just grade 10 science. Distance time, speed times time is distance, right? However, Cal is accelerating, so we're going to have to use a uniform acceleration equation. There's 3 equations, if we look back, that have distance in them. One has the initial and final velocity in them, okay? And acceleration. One has the initial and final velocity in them in time in it, okay? And one has the initial and final velocity in time in it. Okay, the one that we're going to pick is this one. We're going to use the initial velocity of Cal times the time of Cal plus 1/2 times the acceleration of Cal times time of Cal squared. Okay? Because we have our time here, we have our acceleration here. Okay? Now, initially, Cal starts running after 4 seconds, so he starts at 0. So this drops out, because anything times 0 is 0. Right? So we don't have to worry about that part. Okay? So basically, we've got our equation to solve here. Okay? Remembering that Ryan's time is x plus 4, and that Cal's time is just x. So Ryan's velocity was right here, 3.6 meters a second, times his time, x plus 4. Okay? Okay, and then we're going to get the acceleration. I'm going to just divide by 2 at the end, or you can multiply by 1/2, doesn't matter. But I'm going to take this acceleration, 1.2 meters per second squared, and I'm going to multiply it by Cal's time, x squared. And I'm going to divide that by 2. And here's our equation. So you can see that we're going to get a quadratic, right? Because there's a squared term in there. So we're going to expand out our left side. And we're going to simplify what's in front of the x squared here, just by dividing by 2. Okay, say 3.6x. Okay, I'm going to leave out the meters per second and the meters per second squared, because everything's going to work out to seconds. So 3.6x, and then 3.6 times 4 is 14.4, equals 0.6 x squared. Okay, we're going to bring everything over to the right side to make a quadratic equation so that we can use the quadratic formula to find out what x is. Okay, so we're going to subtract both of these. Do some algebra. Okay, quadratic formula, everybody's favorite thing. Okay, 0 equals this. Okay, so we could try and factor it, you know, but it's got decimals and stuff in it, so we're probably going to end up with a decimal answer. We could graph that on Desmos if we had our Chromebooks handy and just see where it intersects. That's another way we could solve this. But probably the quickest math way to solve this is use the quadratic formula. Okay, if you're not familiar with the quad formula, yeah, pull out Desmos, graph that, and see where it intersects. One will be negative, one will be positive, and of course time can't be negative, so you would get an answer. Okay, so quadratic formula is minus b plus or minus the square root of b squared minus 4ac over what was it, 2a, I think? And this is A, this is B, and this is C. Okay, so let's plug in our numbers and see what we get for a plausible one. So that's what x is going to equal. Okay, so let's go ahead and plug in minus B. So minus 3.6 is 3.6. Plus or minus the square root of negative 3.6 squared minus 4 times 0.6 times negative 14.4, and all that whole thing's going to be divided by 1.2. Okay, so we got the 3.6 plus or minus. Okay, and then when we're going to add everything up, so 3.6 squared is 12.96, or negative 3.6 squared is 12.96. I believe, let me check on my calculator here. Yep. Okay, and then 4 times 0.6 times negative, this is going to be a positive. So this ends up being 34.56. So the whole thing under here together ends up adding up to 47.52. Okay, so then we get check here. Then we get our square root of that. Oh, somebody's got a question. Oh, no problem, guys. So where did you jump out there? Do you want me to go back here? Okay, I'll just quickly run through it just because they crashed. So what I did here was we were working on forming our quadratic here. Okay, so I plugged in our numbers for our two distances. Okay, then we have our distance that was accelerated. I plugged in the variables. We ended up getting an x squared because of the squared here. Okay, then we made a quadratic formula. And that's where we were just trying to solve it right here. So this is where we got to this point. Okay, so working those two things together, you get you get 3.6 plus or minus, and this works out to be about 6.9. And that's 1.2 on the bottom. Okay, you're not going to subtract the 6.9 because you can't have a negative time. So 3.6 subtract 6.9 will give a negative number. So we don't do that one because you can't have negative time. So 3.6 plus 6.9 divided by 1.2. And you get 8.75 or 8.8 seconds. Okay, and that's as far as I'm going to go with examples today. That's the more complex example, the algebra example. So for the rest of the period, I've got some practice ones just with some solutions. Okay, that's on the Google page. You can print them off there if you're not from Vanguard. If you're from Vanguard, that's what we're going to work on this morning, or for the second half of the period here. I'll stay online. I'll leave this up on screen for the people that had the crash computer there. Okay? Vanguard people, your solutions are on the bulletin board there. And here is your happiness. Just take one and pass it around. It's not a hand-in. Okay, that'll be coming up at the beginning of next week. So probably on Monday and Tuesday, I'll have a fresh hand-in put up that'll be for marks and all that stuff. That'll be our second one. There's 3 in this unit. Okay. All right, so I'm going to stop the video at this point, but I'll stay online if anybody has any questions. Okay, as they're working through. Some of them are single step, some of them are multi-step. Solutions are posted, so you can look them up as well. If you have questions, please ask me. This is the time to ask. It doesn't count yet, so if you make a mistake, that's fine. Get it fixed. Just put them back. Thank you. All right, so I'm going to mute here, but I will still be here if you have a question.